Hi and welcome to this, our third and final video on the series of vectors and kinematics, and we're going to be having a look at variable acceleration. Again, so this is the variable acceleration ideas that we had from year one, but now we're going to be doing it in terms of two-dimensional motion, i.e. in terms of vectors. So just a quick one, here we go. So we've got a particle P moving in a plane such that time t, the velocity is given by 0.8 ti minus 0.42 t squared j. Find the speed of P when t equals 3. So there's our velocity. So we need the speed when t equals 3. So let's just plug t equals 3 into there. So there's our velocity vector, and we're after speed. So a quick little bit of Pythagoras will sort that out, and that's all fairly nice and straightforward to get us started. Part B, we've got to do the acceleration. Now, acceleration is dv dt, so we've got our expression for velocity up here, and all we have to do is do our differentiating with respect to t and just treat the i's and the j's separately. So if I differentiate 0.8t, that gives me 0.8. So the I component, when I differentiate that, is just going to be 0.8i. And now when I differentiate the j component, 0.42 t squared, that's just going to become minus 0.84t. And there's our j component sorted. So there's our acceleration, and when t equals 3, we've got our acceleration is minus 0.8i minus 0.25 j. And there we go. Right, on we go to C. C is displacement. So our displacement, we're going to have to integrate our velocity. So again, treat the two things as separate. So here comes our integration. So we've got 0.8t, integrate it, is going to be 0.8t squared over 2, hence the 0.4. And here we've got 0.42. Going to be t cubed over 3, so that's minus 0.14 t cubed, and as ever we've got our constant of integration. Now the constant is important because in this particular context we've been given the fact that when t equals 5, p has got a displacement vector which is 3i minus 17j, so we're going to use that piece of information to find the value of our constant. So when t equals 5, we've got that, so our displacement 3i minus 17j is, and there's the, when t is 5, that's plugged into there, t is 5, plugged into there, and so that gives us c as a vector, which means our displacement vector is now minus 0.4 t squared minus 7i plus minus 0.14 t cubed plus 0.5 j. And then we want the position vector when t equals 3, so now let's just put when t equals 3 into there, and that gives us our position vector, and there we go. All nice and straightforward. So it's essentially, there's nothing particularly different about it, about the concepts. You're just dealing with like kind of the I components and the j components as two separate things, and all the rest of the principles just act in exactly the same way.